Okay guys, in the last class we have talked about the how you will be writing this in R type, right? Similarly, next we are going to talk about how you can write it in I type. Okay, so let's start. Okay, in I type is called as immediate arithmetic. That is, we are doing and add and all, but here immediate is there. That is, instead of another register, that is instead of RS2. See here there was RS2 in the previous case in add, right? Instead of that we are adding immediate value. That is, in the instruction itself we can write 4, 5, 6 and all directly. So such kind of instructions are immediate instructions. So here in the place, so there is no function 7 because in subtraction it doesn't work. Okay, function 7 is not there. So you have immediate value. The immediate value is actually 12 bits. So whatever be the value here, it can be 7, 6, whatever be the value here, immediate value, you have to represent it in 12 bit first. Okay, first you're going to represent it in 12 bit. That is 11 is to 0 says that, okay, I am representing it in 12 bits. Then we have RS1, that is 5 bits. That would be the next, the register value here as usual. Then function 3, which will specify, okay, which operation I am doing here, which is 3 bit. RD would have be the destination register. The final value is given in the RD. Similarly, you have opcode. Opcode is 7 bit. Now you have to understand that there are two cases here. The immediate instructions are not only the arithmetic immediate instruction like add, and I, or I, SLTI and all, but there is another instruction, we know load. Load also uses this immediate thing, that is immediate value in the load instruction also. This we have already learned in the module 1 itself, but if you wanted to learn it again, it will be like this. You know, load instruction, just understand the load instruction guys. Load RD comma immediate RS1 would be, that is, if I give you one example, load from the memory, that is from the memory some 4 RS2 or any value. From the memory I am going to, this is the memory address, from the memory I am going to take the value in this memory address and I am going to load it in this RD. That is what load means. That means in this memory address, let us say you have 4x7 something like that. Okay, so in this address means in the memory you have to find x7 plus 4. So this 4 here would be what? The memory is this, in this place what is the value that you have to load it in RD. That is what RD load means actually, right? So you have to understand here that what you have to understand, the value that is here, that is loaded into this RD. So this 4 is an immediate value, that is in this address plus 4 or whatever be the immediate value. So immediate is the, which is represented as 12 bit. So this also immediate load instructions have a different opcode. Arithmetic immediate instruction like add I, and I, SLTI, or I have different opcode, as you can see here in here. And if you look here, there is another instruction type which is coming in I type itself, that is jump instruction, that is JALR. Now this is also like RS1 immediate RD, but their opcode value is also different. So what is our condition is that function 3 values of all of these we have to learn, right? So that I will come across first, but first let us learn the opcode. So in order to learn opcode guys, you have to understand which and all opcode you have to learn, right? You have to learn opcode, and in I type you have to learn the opcode of JALR and also arithmetic immediate operations opcode also you have to learn, and also you have to learn the loads opcode also. This is the case, you have to learn these many things opcode. So I am going to teach you first the opcode values. Okay, okay, let's see. Okay, opcode is here. Guys, check out here. R type opcode we have already learned 0, 11, 00, 11. Now I type immediate ALU kind of operation like add and all. Instead of this one, you have 0, 0, 1, 0, 0, 1, 1. Now if you have load, only last you have 1, 1. And for JALR, it is double 1 first, then triple 1 last. So you have to remember actually how you will remember this is important. So let us understand here. These are the opcodes that we have learned till now. Now these three are coming under I type itself, that is immediate ALU, load, JLR. Now for immediate ALU it is 0, we have learned for R type it was 0, 11, 00, 11. Then 0, 0, 1, 1, 0, 1, 1 if you remove from the first one, if you remove from R type, then you get I type of immediate ALU, and load is easy, last 2 bits are 1. Now for JLR, if it maybe JLR is very rare chance to ask, so it's fine if you don't remember also, but it's very rarely it will be asked. Still, for safety purpose we will still learn JLR. So it is 11, 0, 0, 0, 111. Sorry, 0, 0, 111. Fine. So I will just write it in a very fresh page. I want you to memorize by this, through this video itself. I want you to memorize this. That is my concern right now. Sorry guys, page go a little faster. Okay. I don't have any. I will go to the I type itself, and I will do it there. Okay, this I type page is very messy right now, so I will write it in the S type. So we are going to learn the opcode, guys. We are going to learn the opcode. Fine. So first of all, R type opcode, do you remember? It was 0, 11, 00, 11. Fine. So I saw in I type immediate arithmetic, I told you I will remove this 1 and I will write 0, 0, 1, 0, 0, 1, 1. This is done. Okay, fine. Now for load, I told you load is easy. For load, I told you just last 2 digits are 1, 1. So load is kind of easy. Then we have to learn for JLR. That is the issue where it is coming. JLR is where the issue comes. So in JLR, I told you last 3 is 111 and the first 2 is 1, 1. That is, it is 1, 1, 0, 0, 111 is actually. Okay, I wanted to learn it. I know it takes some time, but still you try to learn it as much as you can through this video itself. Fine. Now function 3 values we are going to learn for each of these. So if you take the function 3 values in here, that is in the arithmetic, in the arithmetic is very easy. Like in here you have learned for add, subtraction is not there here. SLL is there, SLT is there, SLTU is the XOR is there. SRL is the SRA is not here in immediate, or and AND. These are the things which are there in immediate. Okay, the same values are there. For add it will be 0, 0, SLL is 0, 0, 1, SLT is 0, 1, 0, SLTU is 0, 1, 1, XOR is 100, SRL is 1, 0, 1, then 1, 1, 0, then 1, 1, 1. See, if you check, you can just confirm it. XOR it's 100, SRA is 1, 0, 1. See, SRLI is also 1, 0. So these are the same values itself, but here the thing is that we don't use subtraction and shift right arithmetic. These two are not here in this case. That is the only difference that you have to understand here. Fine. If that is okay with you, if that is fine, we will be moving on to the next thing, that is load. Fine. Why did I go this much, guys? Do you remember our page number? I don't. Fine, let's go. These are all our previous classes, guys. Do check that out too to understand it, to understand all the concept. Fine. So for load, if you check, this was a table. It is 0 0 0 0 1 0 1 0 1 0 0 1 0 1. That is same. LB, LH, LW, LBU, LHU. It's so easy as that. LW is the most thing, that is most important thing, that is 0 1 0. It is easy. 0 0 0 1 0 0 1 0 1 0 1 0 0 1 0 1. Fine. So it is like 0 1 2 3. It's not 0 1 0 is fine. 0 1 1 is actually 3. 0 1 1 is 3. 1 0 1 is 5. Okay, so this is 0 1 4. 3 is not there, guys. You have to remember that 3 is not there here. Here 0 is a, 1 is a, 2 is a, then it is coming 4 and 5. So LB, first you have, oh, I'm just getting very annoyed with the slide. They are like going like this. Fine. Okay, guys, because I have write it in very bottom, that is fine. So first you have LB, that is 0 0 0. LB, LH, LW, then LBU, LHU. LBU, LHU, you don't learn that. Fine, okay, you just learn this. LBU, LHU, I don't know, it won't be asked load by. But for safety, you can still learn LBU and LHU. But LB, LH, LW, these 0 0 0 0 0 1 0 1 0. These three things, learn it very hard because it is 0 1 2. Fine, okay. LB 0, LH 1, and LW is 2. Fine. Then it will be very easy for us to learn. So right now we know, we have learned for load also. Then for jump we may have like JLR, that is just 0 0. So you don't need to risk a lot of time in there. So it is fine. Okay, so load. So load we can just learn LB, LH and LW. That is 0 1 2. That is 0 0 0 0 0 1 0 1 0. Fine. And JLR, I told you, for JLR there is no very fancy thing. The function 3 values just 0 0 0. Now guys, I can also have, so remember the opcode. Opcode for R type was what? 0 1 1 0 0 1 1. Now for immediate arithmetic in I type, now we are going to talk about now we are going to talk about all about the I type. That was 0 0 1 0 0 1 1. Fine. Now next is for the load. Load was easy. I have already told you, just 0 0 0 0 0 1 1. That is for load. Then we have learned for JLR. For JLR, the first two digits are 111, then 111. Easy. So I hope in this video itself we have learned this values and all, right? Now we are going to go to the next important thing, that you have to understand that how was the step is written. You have immediate, then RS1, sorry, we were not talking about, okay. You are talking about the I type, then you have the immediate value. Immediate values, then one register is there, that is RS1, right? And the final function 3 is there, then a final result is given in RD, then opcode, right? So you have to revise the format also, guys. In R type the format was you have the function 7 value, RS2 value, RS1 value, function 3 value, RD value, and opcode. Now for I type we have discussed, it was immediate value, that is the first 12 bits, then RS1, one register is the F3, function 3 is the RD is there, opcode is there. This much is done. We just remember the example of an instruction immediate, then you can clearly get. Okay, in immediate, if you remember the example, you have immediate, one register, destination register. You can easily remember through that. Now, next we are going to talk about the store instruction. That is S type. S type is the store instruction. Store the instruction. So therefore, you have immediate also here. There is SB, like load, it is SB, SH and SW, that is, and SW is the most important, like LW. This much are the store instruction. Now what does store instruction say? The value in the memory address which is given, that value you are going to store it in the register. That is what store means actually, guys. Understood? So what is store actually means? So store means the value in this immediate RS1, that is the address, memory address. The value in this address location is stored into this register RS2. Fine. So you have, guys, immediate RS1 is there for you guys. Immediate RS1 is there. The value in this, that is 4 RS1 would be, that is the memory location. In the memory, the value in this RS1 plus very angry with this. The value in the memory location, this is stored into here. So here you have to remember that there is RS1, RS2. There is no destination register, because in store we are just storing the value in RS2. We are not loading the result or showing the result through a destination register. No, we are just storing it in a register. So we have RS2 and RS1. Then immediate value is there. Now you have to remember that the immediate is actually splitted. We have 12 bits are the immediate value. RS2 is the RS1 is the function 3 is the immediate is the. Now immediate, initially in I type we have learned that the immediate is not splitted. It is single 12 bits first. And here you have destination register and only one source register. Here you have two source register, because the value in the address location plus that, this is one source register, this is another store. We are not going to show out any result. We are just storing it. So therefore RD is not there. Destination register is not there, guys. So first of all, you have to understand here what? You have to understand that in the immediate values, it is actually split in a step. First 7 bits are here. That is 11:5 means 11, 10, 11, 10, 9, 8, 7, 6, 5. That is 11:5 means first 7 bits are here in the first immediate. The later 5 bits are in the next immediate after function 3. Then you have the opcode. So here what happened is that, guys, here our immediate is actually splitted. The 12 bits are splitted. Then rest you can write RS2 value here, RS1 here, you can write it here. Then function 3 value, we will learn the function 3 value also. Then the next later bits of the immediate is placed here. Then you have the opcode. Now you have to remember the opcode for store. The opcode for load you can learn, it is 0, last 2 digits are 1, 1, 1. That same thing, but in the second bit you have to add 1. See this opcode? I'll zoom it if you want. We have learned for load. For load we have learned the opcode was 0, 0, 0, 0, 0, 1, 1. So for store, that second bit you're going to change it to 1, then you get your store to you. Okay, now let us learn the function 3 values. Function 3 values of S type. Same like we have learned here LB, LH, LW as 0, 0, 0, 0, 1, 0, 1, 0. Similarly, SB, SH, SW would be 0, 0, 0, 0, 0, 1, 0, 1, 0. It is as easy as that. This is S type. Is it clear? The S type is clear. So in S type, you have to remember mainly is that the immediate split into 2. 11:5 and 4:0. That is how, sorry, not here. That is how the immediate is basically split up. Then you have RS2, RS1, function 3, the rest of the immediate and the opcode. The opcode for S type is 0, 1, 0, 0, 0, 1, 1. Fine. Now we have B type, U type and J type to us. So let's see how many times the recording was. It is actually 20 minutes. Fine. Let's learn the B type. In B type, it is actually branching. Branching, we know. B equal to, B not equal to, B greater than, B less than. These are the different questions or the branching instructions. And in the branching instruction, if you check what does this branching instruction means, that is, if the register value in RS1 and RS2 are equal, then I have to go to this label. So guys, the main problem here comes is this label. We have to understand that where you have to go, the target is this label actually. So we have to convert that. So there is an immediate value you have to find for this label, which is split into 2, like 7 bits and 5 bits here. Then 5 bits for the RS2, RS1, function 3. That is the same thing, but the immediate is also split. The opcode value for B type is what? You have learned store like this 0, 1, 0, 0, 0, 1, 1. Add another 1. That is 0, 1, 1, 0, 0, 0, 1, 1 is B type. But the problem here comes is how you can actually see the label value. What would be the label value? You know, how do we find this? The target where you have to go is the label. That is the PC plus sign extent of immediate that you have to find. So first of all, how you are going to find is very important. Okay, so that we will discuss very detailedly later, but right now you have to understand the structure. We will learn the function 3 value, and opcode for B type is 1, 1, 0, 0, 0, 1, 1. Fine, that is for B type's opcode. Now B equal, B not equal, B less than, B greater than, that you have to 0, 0, 0, 0, 0, 1, 0, 1, 0 is not here guys. Here it is 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So here you have to remember that guys, if you know store's opcode was what? Guys, I have told you the load opcode is this. Okay, then the store's opcode becomes this. So the branch opcode becomes this. This is how you will learn. Okay, fine. This is how you are going to learn. Branch equal to is the branch, not equal to is the branch, less than is the branch, greater than is the, and branch less than unsigned and greater than unsigned is the only thing is that the flow is like 0, 0, 0, 1, 0, 0, 1, 1, 0. So the flow is correct, 1, 0, 1, 0, 1, 1, 1, 0, 1, 1. But the problem is that 2 is not here. The 2 is not. We are starting with like 0, 1. Then you are going to our 3 is also not there. Okay. Then you are going to go 4, 5, 6, 7. So in the branch 2, 3 you have to eliminate. 2, 3 you have to eliminate. Then branch equal to, branch less, branch equal to, branch not equal to, branch less than, branch greater than, branch less than, unsigned, and branch greater than unsigned is the. Okay. So here you have to remember the flow would be 0, 0, 0, 0, 0, 1. Then 1, 0, 0. Then you are going to 4. Not 2. 2 and 3 is skipped here. Fine. Now how do we find the labels value? How do we find the binary number labels value? That is a question, and that we will deal later guys. Right now you have to understand the thing that we are going through the flow. Okay. Now we have U type and J type. Okay. U type and J type is immediate RDO opcode. Immediate RDO opcode is a thing. Okay. The J type JAL is there. Fine. Now guys, we will learn the U type and J type. You have immediate 20 bits because there is in the instruction there is directly immediate to us. Immediate is directly there. And then you have label in JAL, that is you have to jump, right? So you have label in JAL, that is, but in when we were learning JLR there is immediate value, not this, but here in JAL there is a label. First of all, learn this as 20 bits immediate RD opcode, 20 bits immediate RD opcode, and this instructions, that is this instruction like using LUI, AU, IPC and all is not commonly used. If it is used, we will learn it later, but right now we don't need these things. Like J type, JL we can learn, but U type instructions like LUI, AU, IPC and all is not used in most of the cases. Okay, so we'll just skip this for now. And J type, for the jump type we have JL. We have learned 1100111 for what? JLR, and that you have to write here 1. See, here 1 for J type. That is only you have to know. That is this and the instruction is 20 bits here immediate, then RD opcode. Fine. This is the only thing that you have to understand. So opcode right now we have learned for immediate 01100111 for R type. Then if you remove this one, you get I type immediate ALU, load last 11. I type JLR is 11, then 1 later. S type I told you in the load you add 1 here. B type I told you have add 1, another 1 here, you get B type. Now this 2 we have skipped for now. In JL is this, but all of the format U type is immediate 20 bits, then RD opcode. Opcode for JL we have learned in this, that is this, we have add 1 more bit here. Fine. This is the opcode revision. Then function 3 values and now you have to remember these are the things that is actually there. There is no function 3 values in U and J, so we don't need to learn that. Okay. Then you have to remember R there is no immediate. Rest all of them have immediate values. We said I has 12 immediate value, S has 12 immediate value, but that is splitted. No, branch. Branch is actually, I told you, is label. That is also immediate, but that is 13 scrambled. U upper have 20 bits. J has 20 bits. Okay, 12 split, 13 scramble, 20 upper, 21 scramble. This is important. Branch has 12 bits, 13 scramble. U is 20 bit, J is 21 scramble. Fine. I is 12 bits, S is 12 bit, B is 13 scrambled, U is 20 bit, J is 20 scramble. Okay, these are the immediate bits.